now let's dig into the Rust analyzer. So we can just use this. Here. Let me just get that aligned properly with the preview. There it is. There it is. Yeah. And Firefox looks good. Okay. We should have the Rust analyzer. There it is. And let me see. Can I easily view issues here? The problem is I'm not assigned to it, right? I've just kind of written, can I have a look at this? And they were like, yeah, sure. Okay, let's add a stream marker as well before I forget and do a proper intro. Okay, so to the YouTube folks, I guess. We just finished editing a video. Now we're gonna get started on Rust analyzer issue. So let's just find the issue, since I guess I will have to do that through the GitHub UI. And so we just can talk about what we're gonna do. Oh, I was mentioned in it actually. Can we mention? There it is. So this is 1302. Here it is. I guess we'll just go to the web because I don't know how to do what I want to do in the CLI yet. So we'll just go there. Okay. So basically what we want is that in this case, when you're writing extern create, it should in the autocomplete use these creates from this extern create prelude. Simple enough in concept. So I figured it was a good way to relearn the Rust analyzer codebase. This person had claimed it, but they didn't finish it, fair enough. And then there's some instructions here. So we want to add you'll see I have actually kind of already done this, but add an extra case here for our case with the extern create. And then we want to deal with that case here, I think. Yeah, like your person wrote, constructing it. And then add some new completion module. So very nice, clear instructions. And then the other person here, Spaceface, shared the progress they did make, which was very nice. So we'll take a peek at that as well. So that's kind of the idea. And we'll see here in a moment. Oops. Yes. I'll make this narrow. And then we want to go to also, just because I'm lazy, I guess, I'll just copy in the next file for aim, which should work. So we don't have to spend time on setting that up now. all set up. And if we look at the diff, what we've done so far is we've added this extra case here, just called extern crate. We probably want a different thing for our context, but for now I'll just use an optional string because I didn't know anything better. And then I don't know why the extern block is there. That should probably be removed. I need to get but this extern crate is kind of the case we want to add. I don't know if we've added it in the correct place yet, but we will figure that out. So let's do a helix, and we'll go to analysis. What was this called? Analysis.rs. Under context. And the Rust analyzer is gonna do its thing. Kind of getting meta here, working on the Rust analyzer with the Rust analyzer. In an editor written in Rust. Okay. Can we jump to the next change? That would be kind of cool. Let's see. Go to I guess not. Is there a symbol picker? Okay. We will just search for crate, there it was, and we'll just delete this. Okay. So it is unused, fair enough. Now, a nice thing to do now would be to somehow add a test, which I have absolutely no idea how to do at the moment. So, but the previous person who did some work on this issue, let's just see how is our rendering doing. Halfway. Okay. The previous person here did add a test, so let's have a look at that because it looked kind of confusing to me. So this is a new module, so I guess we may as well add that too, actually. Still am not entirely sure on how to create a new buffer. Open source lib slash, where was it? ID crates ID completion. Okay. So we're gonna do crates, ID completion, and source. And there is a completions here, I think. Yeah, and then extern crate, I think we'll call it. Extern create.rs, nice. And then what else? So we use that here. That makes sense. let's just import it, because otherwise we're not gonna get any Rust Analyzer help on it. I'm really curious how these tests work, because there's a check function and I don't know what's the check. Check. Oh, the check is here. Test completion list, no keywords, I guess. Interesting. It looks like there's some testing help utility. So if we go to file picker, can we do file picker a current working directory? Seems like not really. Okay. So if we go to the, what is it, context.rs, or not context.rs, completion.rs, yeah, I think all completions, I guess. Then we want to import thing. Oops. Okay, so let me think. GL to go to the end of the line. Let me do mod. Extern, great. Nice. File not found. Okay, I mean, it looks like it's not there. Is that because we haven't saved it, I guess? Okay, there we go. So, if we then go to thing again, can we add some tests? Also, let's have a look at how other completions work. So let's say the use one. The use seems kind of relevant, right? That's kind of similar. Because what we, I guess just to show that, what we are gonna try to, we wanna have the use, maybe it's just extern create actually. Extern create something. We want the this to be all completed, which I guess it isn't at the moment. That's what I think this issue is about. I guess we'll find out if I'm mistaken. So here we complete the use path. Can we split this somehow? That's kind of not super nice, but okay. So we can use this as inspiration. So we have a public, a create public function, very sensible, which just, oh my god, there we go. Fn complete extern create. Wow, I am incapable don't know exactly what we want yet, so we'll just leave that. We will actually complete. All right. And let's try and understand what it is doing. Also, let's see if we can figure out how to manipulate these windows in Helix. So we want to resize, expand. Okay, I don't know. We just have to make do. So what do we have here? We have a match on the qualified. Oops. A match on qualified. I don't know what qualified is. Okay. Path context at path completion context. The state of the path we are currently completing. All right. That seems kind of relevant to me. And then we match on qualified. And what we're qualified with. Oh, wow, okay, this is not great. So you can't see the whole line at once. I'm sure there's a way to configure that. Okay. Here's the window. Okay, let's just see. Here are the window related controls. So we can go to the next window, split, transpose split. Go to file and selection. Oh, that's cool. Close window. Nothing about resizing. Okay. Anyway, let's just close. This was not the one I wanted to close. But okay. So now we can just view everything here. That's a bit easier. Yeah, so we match on this qualified, and then what are we matching on here? That it match with, that it has some resolution, okay. Some path resolution. Say if not preceded by self, only show self in new use tree when the qualifier doesn't end in self. Okay. Not preceded by self. Keyword self. quickly show why that is happening. And then we look at what is already imported. And then what? If use tree.path as ref is some path. What does that mean exactly? We look at the parent use tree, and if the path there is equal to the path in our qualified statement, then we go through the tree and then what? Okay, not sure I fully understand why this is happening, but let's move on. And we have a different. Oh, we're still inside this. Okay, we're still inside. Yeah. So now we're matching on the resolution. Yeah, we have some resolution. Okay. And how do we scroll? How do we scroll? I don't actually know how to do that. Scroll view. ZK CJ. Okay. But that's not super nice. Scroll view. Center, can we do that? So if we do what? If we do ZZ, okay, that's nice. So we can still move stuff and then. Cool. All right. Then we look at path resolution. Module. What else do we have? Qualified absolute. So what does that mean? I do not know. Is there some docs on the qualified? Okay. The qualified enum. So we have, there's no qualification. Okay. And there's width. How many super segments are present in the path? This would be none if path is not solely made of super segments. Yeah, okay. Otherwise it would be some count of super. Type anchor. Well, the path is an absolute path. Okay. bit annoying that it takes 2 keystrokes to scroll. Or like, I was finding it takes 2 keystrokes in Helix, but I can't just hold down Z and J and then just scroll up and down. Might have to add that to the config, I don't know. Yeah, I find it's nice to be able to scroll a bit instead of doing like full page jumps when you're just browsing. Oh, I should edit the title of this stream. Okay, so that was not super helpful, but fine. Only show modules and non-standard enum in fresh use tree. All right. Where do we go from here then? Because I think this case, the use is probably more complicated than what we are trying to do. But because you can have like a long use of things, and with the extern query, I think it's a bit simpler. Let's have a look at the other completions. Completions slash. Oh, it's nice with the file previews. I see this hit macro. I've seen it a few places now. What does it do? Hit a mark with a specified name. Not sure what that means exactly. Example. Safe divide, okay. Divisor. Called mark hit, return 0. Hit a mark with a specified name. Yeah, I don't get it. What is the... This is actually hit. Trade hit. Okay, I don't know. Hopefully we'll figure that out at some point. It might be worth also, there was some docs which are probably worth looking at actually before I confuse myself. If you want to contribute or just curious, check the docs dev folder. Seems like a reasonable thing to do. Okay, contributing, quick start. Ordinary Rust project organized as a cargo workspace. Built on stable and doesn't depend on C libraries. Very nice. Can we do cargo test actually? Let's try that. I have not done that. We probably can't now because we broke stuff, but we might have broken stuff. Yeah. Well, I'll try again later. So, code style. Oh, code style and review process. Let's have a look at that. That's kind of relevant. Our approach to clean code is twofold. We generally don't block PRs and style changes. At the same time, all code in Rust Analyzer is constantly refactored. It is explicitly okay for a reviewer to flag only some nitpicks in the PR and then send a follow-up cleanup PR for things which are easier to explain by example. Seeing the original author. Very pragmatic. Sending small cleanup PRs like renaming a single local variable is encouraged. When reviewing pull requests, prefer extending this document to leaving non-reusable comments on the pull request itself. Okay, interesting. General scale of changes. Everyone knows that it's better to send small and focused pull requests. Problem is sometimes you have to rewrite the whole compiler, yeah. And that just doesn't fit into a set of isolated PRs. The main things to keep an eye on are the boundaries between various components. There are three kinds of changes. Internals of a single component are changed. Specifically, you don't change any pub items. A good example here would be an addition of a new assist. 2. API of a component is expanded. Specifically, you add a new component. Specifically you add a pub use re-export from another crate, or you add a new line to the dependency section of the tunnel. Okay, I messed up the things here. We'll try again. Number 2, API of a component is expanded. You add a new pub function, which wasn't there before. A good example here would be expansion of assist API, for example, to implement lazy assist or assist groups. Okay, anyway, wow, this is a serious, okay, let's go. This is a serious document. For the first group, the change is generally merged as long as it works for the happy case, it has tests, doesn't panic on the unhappy case. For the second group, there's a lot more scrutiny, iteration. Okay. Often you start doing a change of the first kind only to realize that you need to elevate to a change of the second kind. Probably ask you to split the PR. Changes of the third group should be pretty rare. There's no process. Okay, I like these comments. They're very pragmatic. I can recognize a lot of my own experience. Note, if you enjoy this abstract hand waving about boundaries, you might appreciate what's this system boundaries. Oh, interesting. I'll have to go through that later. Crates. We try to be very conservative with usage of crates. Dependencies, don't use small helper crates. Tools either allowed. If there's some generally reusable bit of code you need, consider adding it to the standard X crate. A useful exercise to read cargo.log and see if some transitive dependencies do not make sense for us to analyze them. Alright. Rationale: keep compile times low, create ecosystem pressure for fast compiles. Reduce the number of things which might break. Okay. Commit style. We don't have specific rules around Git history hygiene. Maintaining clean Git history is strongly encouraged but not enforced. Use read-based workflow. It's okay to rewrite history during PR review process. After you are happy, I might have to steal some of these guidelines. They align pretty well with how I develop AIM. After you're happy with the state of the code, please use interactive rebase. Yes, to squash fix-up commits. Avoid mentioning people in commit messages. I wonder if that happens sometimes. I guess it does since they put that down. And pull request descriptions. They are added to commit messages. To commit message by boss. Such messages create a lot of duplication. Yeah, okay. If possible, write pull request titles and descriptions from the user perspective. Nice. Nice. This makes it easier to prepare a changelog. If the change adds a new user visible functionality, consider recording a GIF with peak, pasting it into the PR description. Okay, I did not know about this. Okay, I have actually tried to use this, it just wasn't working for some reason. But okay, this is nice. Nice. That makes it very, I guess, easy to see what you're trying to, the change you're proposing does. To make writing the release notes easier, you can mark a pull request as a feature, fix, internal change, or minor. Minor changes are included from the release notes, while the other types are distributed in their corresponding sections. Nice. This is also very pragmatic. Clean history is potentially useful, but rarely used. Yeah. But many users read changelogs, including a description and GIF suitable for the changelog means less work for maintainers on release day. Clippy. We don't enforce Clippy. A number of default lints have high false positive rates. Selectively patching false positives with allow Clippy is probably worse than entirely disabling a problematic lint. There's a cargo lint command which runs a subset of low false positive lints. Careful tweaking of lint is welcome. Of course, applying Clippy suggestions is welcome as long as they indeed improve the code. Pretty pragmatic too. I might have to pull down the blinds. Interesting, let's have a look at this. I haven't yet experienced this with Clippy. I've been pretty happy with it, but obviously they've had much more time with Rust than I have had. This makes sense. If you need a conservative option, then maybe the default lints aren't that great. Let's see. Let's see. The philosophy of Clippy is to be helpful, and sprinkling of allows is encouraged. We're happy to downgrade lints if they are too noisy. In the past months, I was careful to only allow new one by default lints if they are an obvious code improvement. But this was always my own judgment, plus the contributors, and it's only some initial classification, not backed by any analysis. That makes sense, but for me personally, explicitly allowing lints and explicitly configuring linter is a big red flag. In the context of Rust, the compiler already handles most important lints, so Clippy's philosophy and my philosophy are directly in conflict. The moment I solve this by not using Clippy, I see conservative as a way to make both works. Okay, so I just agree to disagree, I guess. Interesting discussion. Good stuff. Code minimal tests. Most tests in Rust Analyzer start with a snippet of Rust code. These snippets should be minimal. If you copy paste a snippet of real code into the test. Make sure to remove everything which could be removed. I might just go block the sun because it's hitting my face. So I'll be back in 2 seconds. Probably not quite 2 seconds, but 5. Okay, it's mostly dealt with now. So, minimal tests. It does make sense to format snippets more compactly by placing enums in a single line, as long as they're still readable. When using multi-line fixtures, use unindented raw strings. Okay. Rationale. Less to read or to scroll past, easier to understand what exactly is tested. Yeah, okay. Nice. Marked tests. Use these checks when testing specific conditions. Do not place several marks into a single test condition. Do not reuse marks between several tests. Interesting, so I saw, this is the macro we were looking at, but I saw it outside of a test. So I don't know what this is exactly. Marks provide an easy way to find the canonical test for each bit of code. Okay, this makes it much easier to understand more than one mark per test / code branch doesn't add significantly to understanding. Verify that your tests exercise the conditions you think they are exercising. Okay, we'll have to go back to that. Should panic? Do not use should panic tests. Instead, explicitly check for non-error. Nice. Why? Should panic is a tool for library authors to make sure that the API does not fail silently and misused. REST Analyzer is not a library, and we don't need to test for API misuse. We have to handle any user input without panics. Panic messages and logs from the should panic tests are confusing. Do not ignore tests. If the test currently doesn't work, assert wrong behavior and add a fix me explaining why it's wrong. Rationale, noticing the behavior is fixed, making sure that even the wrong behavior is acceptable. I mean, not panic. Okay. Interesting. Function preconditions. Right, let's just see how. We probably won't go through all of this, but we'll just see, at least now, what other parts are relevant. Like the mark thing was nice to see, and how the tests are done and stuff like that. So function preconditions, express function preconditions in types and force the caller to provide them. Yeah, that makes sense. Rather than checking in call E. Makes control flow explicit. Yeah, nice. In the not as good version, the precondition, yeah, that makes sense. is this? When checking a Boolean precondition, prefer if not to negative variant. That's interesting. I have not seen this before. It's useful to see the invariant relied upon by the rest of the function clearly spelled out. Okay. Interesting. Okay, so I guess this is also a separate thing. Avoid splitting precondition check and precondition use across functions. Good. If something something, do this. If starts with this, use it. What's the alternative? If is string literal. That contains. Okay, I see, because then maybe it's harder to follow what is happening. Is that the idea? Yeah, so the precondition check and the usage are in the same block. Non-local code properties degrade on the change. Yeah, that makes sense. Did we just get someone in the Discord actually? Or is it a different Discord? Ah, yes. It's probably the Leptos Discord. Let's have a look. Where is that even? Where is that sound coming from? Wow. I need to stop this somehow. I must have another tab somewhere. One sec. Okay, so I had a different Discord tab hiding in a different workspace, which is gone now. So back to business. These are some pretty nice guidelines, I have to say. Also, our video finished encoding. So let's have a quick browse of that. It is very long, but yeah, there's no way around that unless I want to spend more time editing today. Which we do not. Let's save that. Okay, so back to these guidelines. Control flow. As a special case of the previous rule, do not hide control flow inside functions. Push it to the caller. Makes a lot of sense. Assertion library, prefer standard X never to standard assert. So what is this? Standard X never. Asserts that the condition is never true and returns its actual value. Okay, so let's see why I want that cross-cutting. Ah, that comes. Wait a sec. That's under architecture. Okay, I'll have a look at that later. Getters and setters. If a field can have any value without breaking invariants, make the field public. Conversely, if there is an invariant, document it enforce it in the constructor function. Yeah, makes total sense. Should just be doing that in general. So this is interesting. One thing I've been considering myself. So getter should return borrowed data in like my Rust journey. Like when you return borrowed data, when should you not? So why do we want to do that here? Rationale: we don't provide public API. It's cheaper to refactor than to pay getters. It's cheaper to refactor than to pay getters rent. So what does that mean exactly? Non-local code properties degrade under change. Privacy makes invariant local. Borrowed, owned types. Like that. Disclose irrelevant details about the internal representation. Obscure correctness. I think, okay, so that's, I'm not sure that makes total sense to me. I'm not sure I fully understand what that paragraph means. So for this first sentence, we don't provide public API, so this is not a library, right? Does that make sense? Yeah, so we don't provide a public API. And why is that important? That's because, well, my interpretation, I guess, is that for public API, an owned type can be nicer to use. Whereas when it's all just internally passing stuff around, there's no reason to pay that price, so we can just refactor instead and avoid the overhead. I think that's the idea, but I don't really know. I'll have to think about that. Well, maybe let's look at the example actually. So good. So we have a person and we just return the borrowed data. Yes, bad. Not returning borrowed data. Okay. Borrowed own. Yeah, okay. That one's not quite as clear, but I think, yeah, they're like separate properties. It's not just one thing they're arguing here. So here, since it's all internal, there's no reason to have to provide an own type. Okay. And non-local code properties degrade under change, so that's why we want to keep things private, I guess. Privacy makes invariants local, that makes sense. And then there's the whole borrowed own types, which you should try to avoid, which also makes sense. So I guess, yeah, kind of makes sense. But it was, yeah, I don't know. I don't know if I'm actually interpreting that as intended. Useless types. So that's interesting. So let's see. Borrowed slice t vec t. Borrowed vec t. Makes sense. Yeah, so I think those is just about using better borrowed types instead of like borrowed owned stuff. That makes sense. Constructors. Okay, anyway, I could spend a lot of time going through this. I really like talking about kind of code decisions. But we have to get a move on. So is there any important information here? Refer separate functions or parameters. Premature pessimization. Yeah, avoid writing code which is slower than it needs to be, because that actually matters for a tool like Rust Analyzer, right? This I've also been thinking about. So pushing allocations to the call side, so trying to avoid hiding allocations inside your function. So whoever is using the function can decide, do they want to allocate stuff or do they want to try and do something else? I think makes sense. Because yeah, exactly here. If you accept the borrowed one, well then you're gonna end up cloning it if you need to own the data, right? So if you need to own the data, expose that to the caller so they know that. Exactly. Makes a lot of sense. Avoid monomorphization. I know we said we have to move on, but these are kind of interesting. Avoid making a lot of code type parametric, especially on the boundaries between crates. So good. We want something that implements if and mood. Okay. Frobinicate impl f. Lots of code. Interesting. So this just calls, yeah, this calls Frobinicate. I'm not sure I really understand that example. Let's try again. The bad case, we just have a Frobinicate function that accepts an f in mood, and this also accepts an f in mood. Avoid making a lot of code type parametric, especially on the boundaries between crates. Is it the... No, I don't know actually, because we have the din here. Yeah, this example confuses me. I'm not sure how that makes code less type parametric. Avoid asref polymorphism. Rust uses monomorphization to compile generic code. So that's just to minimize, I guess, compile the amount of code that needs to be generated by the compiler. And that makes sense when it's not a library, I guess. Okay. Okay. When we actually submit a PR, we'll have to go through these again. Yeah, I'm definitely taking these and using them for aim. Very nice. I was unable to fully block this out because of the structure of my windows. Oh, what is this? It looks like, damn, the Leptos guy, Greg Johnson, he's working weekends. Let's just do a quick intermission and have a look. Because I was having some issues with the... Oh wow, it's already merged. Nice. So basically, I had an issue when compiling Leptos, only inside a workspace, where whenever I added the gRPC version, or the web gRPC client, Photonic, and after a specific version of Leptos, things would just fail and go wrong, and it made no sense. And I was convinced it was a cargo error, because it was only happening inside a workspace. But after some discussion on the Discord, and one of the other people there, Remo, found an article or something about the cargo feature resolver, which I had no idea even existed. It turned out that there was some different behavior inside a workspace and outside. So when cargo chooses which resolver to use, there was a pre-2021 edition one and then a new one. In a single crate project, it can just look at the Rust edition and use the appropriate resolver. In a workspace, that information is not there, so it defaults to the old resolver, which meant that when feature gating non-WASM code, some weird stuff could happen, which I don't know why, but basically you could end up with non-WASM code inside your WASM build, which of course makes things not build. So basically all you have to do is enable a new resolver in your workspace and it works. So that's just what this documents. So that's nice. That was merged very quickly. This looks great to me. I actually understand this much better after reading your short description here than after following along with the conversation. Really helpful. Nice. Let's go. So we'll just delete this branch on our thing. Awesome. Awesome stuff. I'd like to do some work on Leptos too at some point, but I guess we have enough things to look at for now. Anyway, back to Rust Analyzer. Yes. So anything else? Awesome stuff. Damn, this document is like gold. And it's nice to read stuff from someone who has like a lot of Rust experience. I have some Rust experience, but clearly not as much as this person. And also like more experience working with other people on Rust, which I mean, I don't have anyone apart from the open source stuff I'm starting to do now. I don't really have anyone to collaborate with on Rust, so it's very nice. It's very nice to kind of read about some of the experience and rationale behind doing things a certain way. Okay, let's see. I guess architecture is probably relevant. Analyze, so we get input data, analyze, semantic code model. The input consists of, let's just see, what is the time? 1 o'clock, shit. The input consists of test files, information about project structure, and the crate graph. The crate graph specifies which files are crate roots, config, with which config lines are specified, and the dependencies. That's the ground state. The Analyzer keeps all this input data in memory and never does any I/O. Because the input data is source code, which typically measures in tens of megabytes at most, keeping everything in memory is okay. Makes sense. A structured semantic model is basically an object-oriented representation of modules, functions, and types, which appear in the source code. This representation is fully resolved. All expressions have types. All references are bound to declarations. This is derived state. The client can submit a small delta of input data. Ah, that makes sense. Like when changing a file, and get a fresh code model which accounts for changes. The engine makes sure that the model is computed lazily and can be quickly updated. Awesome. Entry points. Main.rs, that's spawns the LSP. The handlers. Handlers, the RS implements all LSP requests and is a great place to start if you're already familiar with LSP. I'm not at all. And analysis and analysis host types define the main API for consumers of IDE services. Okay. Code map. Architecture and variance section. Rules at the boundary are different. Yeah. So, this is Rust Analyzer's build xtask build system. We use Cargo to compile Rust code, but there are also various other tasks like release management or local installation. They are handled by Rust code in xtask directory. One thing I really like, I guess I've been liking lately, although I haven't really tried it much in practice. I more observed others do it and kind of tried to do some of it in AIM, but it's moving as much of the compiling build tasks, having that like inside the project itself, so you don't need like a whole separate suite of tools. I think that makes a lot of sense instead of ending up with like a huge makefile situation. So let's have a look at what was it called again? Xtask. Okay, wow. So there is like a lot of things in here. Cool. So this is just like straight up build commands in Rust. Let's go. They're not expressible with just Cargo. Notably, it provides tests via Cargo test xtask for code generation. Cargo xtask install for installation of Rust Analyzer server client. Interesting. So you have a bunch of commands. Yeah, so it is like a custom build system in the project itself. I think this approach makes a lot of sense. Especially as for like more complex projects as they grow. Because like right now in AIM, for example, I've just been chucking stuff in a just file. And you can definitely feel the limitations of that as the project increases. Things become less and less manageable. Whereas here, I feel like it's inverse. Like it's probably more complicated in the start, but then as the project grows, you can deal with that complexity with an appropriately complex tool like the language itself. Seems like that makes sense. Okay, cool. Editor, so that's a VS Code plugin. Okay. So there's a first party plugin for VS Code. That's interesting. We have lib, so Rust Analyzer independent libraries which we publish to crates.io. Interesting. Crates. Crates/parser. It is a handwritten recursive descent parser which produces a sequence of events like start node X, finish node Y. It works similarly to Kotlin's parser, which is a good source of inspiration for dealing with syntax errors and incomplete input. Original lib syntax parser is what we use for the definition of the Rust language. Okay. Tree sync and token source trace bridge. The tree agnostic parser from grammar and Rowan trees. Yes. Architecture environment. Okay, what does it say? The parser is independent of the particular tree structure and particular representation of the tokens. It transforms one flat stream of events into another flat stream of events. Okay. Token independence allows us to pass out both text-based source code and I don't know what TT is. TT-based macro input. Tree independence allows us to more easily vary the syntax tree implementation. It should also unlock efficient light parsing approaches. For example, you can extract the set of names defined in a file for typo correction without building a syntax stream. Makes sense. Another invariant, parsing never fails. The parser produces vec error rather than result error. Okay, that's good to know. So we don't get a result, we just get a vec of some errors. The Rust syntax tree structure and parser. Great, syntax. Interesting. Tests are mostly data driven. Okay. Let's see if we can maybe speed this up a bit and go to parts that are relevant for us. So right now we're in /IDE, I believe. /IDE. IDE completion. IDE completion. So let's have a look at that. TT is a token tree. Okay. Is there a note on IDE? There's nothing for IDE completion. Well, I guess we'll just look at the cross-cutting concerns in that case. Cross-cutting concerns. We don't introduce new stability guarantees. We leverage existing ones. What does that mean? The IDE API of Rust Analyzer are explicitly unstable, but the LSP interface is stable. And here we just implement a stable API managed by someone else. Yeah, okay. Rust language and cargo are stable, and their primary inputs to Rust Analyzer. The Rowan library is published to crates.io, but it is deliberately kept under 1.0 and always makes somewhere incompatible upgrades. Another important example is that Rust Analyzer isn't run on CI, so unlike Rust C and Clippy, it is actually okay to change runtime behavior. Okay, cool. Code generation. Some components are generated through automatic processes. Okay, that gave some useful context. There's a lot more to dive into, clearly. But this is where we originally came from. So contributing quick start. What else? This is a cookbook, CI, launching Rust Analyzer. Yeah, so the best way to see how it works is to find a test and execute it. I think that gives us enough to go on for now. So let's go back to our browsing of other completions. So here we complete, what are we completing? Visibility specifier. So this would be like pub or pub crate, I assume. Yes. And how do we do that? So we have this resolution qualified with yes, and then we want to say try completing next child module of the path that is still apparent. Current module. Next towards current. So here we have the mark. What is this? Visibility qualified. That's not even in the document, is it? No. Yeah, I don't know. but it sounded like based on the docs that it's something to do with testing, something coverage. But okay. If there's a next name, we add the module to this to the completions. So I guess the completions are the list of completions currently being built. And we add module which requires this information. Okay. Qualified absolute. And here we do nothing. Okay. That's interesting. And if there's no qualification, we add a keyword. Add name ref. I don't know what is happening now. So let's try and add some kind of skeleton, I guess. So if we go to our extern page here, so I guess we definitely want to accept something. Now is also probably a good time to look at the work the other person had done as well. Here. Yeah, so they accepted basically a similar thing. Completions, completion context, and a name ref, which I guess will be the name of the crate. Hello, Buffer 0xAA5. How are you? On Saturday? On this Saturday? Ah, shit. Okay, so I think accepting those things makes sense. So we want a mutable completions. Yes. And we want a context. So that's completion. We don't really care about the lifetime for now. Hopefully we won't have to care about that. And then there was the optional name ref, at least in this person's work. And I'm going to assume that this is like if we have a partial crate name, we want to work based on that. So if you've started typing, you want to use that information, obviously. So we'll just use the same name. So that's the name ref. That's an optional, I think. Now this might already be going against the style guide, actually. If we have a look at the style guide, Good. Bad. So we want to move the ref inside the option when possible. So, oh, we are doing that here actually. Perfect. And then we have the name ref. Is that what it's called? AST name ref. Import. Thank you. Okay. So this should give us enough context. Do we need to return anything? I guess not. That's interesting. Okay. So what's the first thing we want to do? I guess we want to match on the context somehow. Or we want to look at the context at least. So let's grab the context. And then what? What do we have here that's useful? Maybe the qualifier context, locals, depth from created root. Not sure. Let's have a look again. So we grabbed, that's makes sense. We want to see if the name ref actually exists. Syntax.text. Okay. Process context.process all names. Process all names. Why? What does process all names even do? Process all names. A version of semantic scope process all names that filters out doc hidden items. Interesting. So this is actually interesting. So we can see the docs for this in autocomplete, but if we try to go to the definition, we cannot. So I'm not sure what is happening there, but what we can do instead is search for this in our global search and just see how it is used. So here we can look at how is it used to create function names. So semantic scope to process all names. Okay, so we're making the function name, then we push names in scope, we push that. We push the name to names in scope, okay. That's interesting. Because I mean, when I read that, I would think, okay, there are names in there that are not functions, but I guess I might be mistaken. Okay. Let's go back. What else is there? So here's the definition, it looks like. A version of semantic scope process all names. process all names. So let's see, what does it do? It goes through, so basically you're applying a function or closure, whatever, an f and mood to all the functions, to all the names in the scope. So we say resolver, scope def, module definition, scope def unknown, import self, add self, generic parameter finding. Okay. Okay. So let's try and read this again. Okay, so we're applying this to all the functions, all the names. And then we match. What the fuck? We match our name ref here, and the name and the res. And then we say what? So if we have a name ref, and if we have a scope, so a module definition in our res, which I don't know what is res. Can we see that? Res. Is that resolution? Yeah, so res is a scope def. What is a scope def? Okay, and what is a module definition? The definitions which can be visible in a module. So okay, so if we're looking at a module, we have a name, we're looking at a module, okay. So that's this match case. And that's the only one we have right here in this draft. If the module is a create root, then, and what? And name ref equals name. Manually add a module completion item since add module is not usable without path context. Interesting. Okay, I just got an idea. We can write a test and then see if we can kind of make it succeed. So if we can just forcibly complete or put the correct completion in one specific case, just to see if we understand how completions are made. So let's try that. No tests here. Okay. So let's try that. So we can do, let's see if I can remember this. Config test. Test. Test fn if extern create and include we probably want to return some kind of result in the test, or not in this case. We'll fix that later. I think according to the star guide we do, but we don't really care about that right now. Okay. So what do we want to do? We want to have a test. So our test case is whoops, something like this, and then what? We'll just grab this for the moment. I'm not sure if there's some special syntax that allows the tests to be set up maybe smarter. Maybe I'm just hoping for it too much. Okay, so we have lib, rs, create main, deps, other create, extern prelude, other create. And then if we have O here, let's say OT, we expect that other crate to be completed. We expect the other crate to be completed. Expect MD crate A, MD crate B. So I think this is what you would see, the MD crate A. So if we do, let's see if we can see this. So if we try to complete a crate now, use super here. I think here this MD maybe becomes this module, and then test utils is the name, just to kind of give an example. So MD test utils would then become test utils module or something in the actual completion that we see. That's the hypothesis for now. So the completion list, no keyword. So let's try to get that completion list. Can we import the completion list? Completion list, no keyword. Is this so many docs? Not really. Okay. Completion list, no keyword. And what do we give it? We give it a picture, so we give it this case. So we give it this case. We get this list back, and then we expect. For now, we'll just use a normal assert, I think. Or did I mess up the completion somehow? I feel like I did. I'm using that syntax wrong. How should it? R hashtag. I forgot the closing hashtag. So it should be. There we go. There's our raw string. I think it's a raw string. Okay. So we want to expect want to expect. I don't quite understand. We give it the expect, and then we expect .assert. Ah, I see. Okay. So for now, we just do assert equals. Doesn't really matter. Module. I guess we're expecting the other crate for now. Yes. So we probably can't run this because we weren't really building before. So what is one run here? If we go to, let's get this to build. Go to completion, completions.rs, and here we're not covering all cases, so extern crate is not matched. So name ref kind. So if we do name ref kind external crate, why is that a 0? That's an interesting suggestion. We'll just put none. No, actually, we'll just do anything. But we just want to see it fail. 2 failed. Add external crate completion. Okay, is that enough? No. Oops. Yeah, we don't care about that. Oops. Let's see, any more diagnostics here? Unexpected end of, that makes sense. So we just want to assert that these are equal. Can't compare a string with do we just get a string out from this? We do? Okay, easy. In that case, we'll just have this be a string. There we go. More diagnostics. Complete extern crate is never used. Yes, we kind of know that. Okay. So now, at least here, I guess we can just try and run all the tests now, just to see, and then we can run our test. Nice, it failed. Okay. Metadata line 0 has invalid indentation. Let's have a look at the indentation here. That's all Okay. So if we do this, good line start. Boom. Is that better? Nice. Okay, so nice. So basically, we're just getting no completion. Let's see if we can get a completion. If we do something like use let's see if we actually understand how this one works. I like that the tests are so fast. I guess part of that is that Rust Analyzer doesn't really have any external dependencies, so you can just blast tests. Let's go! So this is starting to make sense, right? So why do we get this completion now? That's because now we changed our test to have the use here, and the use key already has, or keyword or whatever, already has completion implemented, right? So when we type use and then OT, and our cursor is now here at $0, and we have told it that one of the dependencies is other crate, right? Then it suggests other crate. I don't know what this stuff down here does exactly, but we'll figure that out. So this is like the context. Yeah. Very cool, very easy to test. So we'll put that back to extern crate OT. And then we'll just figure out how to move. I cannot, there we go. Run the test again. Nice. So let's see if we now can like hard code some completion here. So I think one place where we should be using our completion, let's say, is if we go up here and we say completions on RS. So we're not actually hitting the extern crate, and that does make sense, I think. But let's just go back and see where they changed it. So in completions, they had this pattern. And then in context, we have that. And in analysis, so we're missing the analysis part, I think. So if we go to analysis, analysis in context, and we should have an extern crate somewhere, but I'm pretty sure it's not correct. So where is this? 625. Okay. So here they have the ST extern crate. So can we just do that basically. With this, let's have a look at the structure. Would this even be different? What are we inside right now? We're inside a segment. And where did we make the change before? Type location is condition. Macro call. So I think path kind. Okay, so we put this in some place weird, which is why it's not even panicking, right? It should be panicking since we have a to do. So let's try to go and put it here. See, does this make sense? We're inside a segment. I think it makes sense. So now hopefully we will crash or panic. Yes. So here we are. We have reached this point, right? Very nice. So now we want to actually do something here. And what do we want to do exactly? We want to return some kind, it looks like. Name ref kind. Ah, yes. So we have made a slightly different kind. Our kind equals kind name ref that's weird. It feels like sometimes the LSP dies when I'm editing here. I'm not quite sure what is happening. We do have the name ref kind, so I guess we just try name ref kind extern create, and I think we could just give it a none, and can we return that? I don't know what we need to do here exactly. We just run the compiler and see. Expected struct path segment found enum. Okay, so how do we create? It looks like there's some make res. We can try that. Oh, thanks for the follow, Danush Arch. I hope that's pronounced somewhat recognizably. Return some make res in kind. Oops, don't want that. Slowly getting the hang of Helix. Now we should get a new panic at the next to-do in the chain of to-dos. So this, let's just see. Panic, so we did get a panic. And this panic is in completions.rs. So that is a very good sign. completions RS. And this is the next panic. Let's go. So now even here we should actually be able to hard code our thing. So we don't want that. We just want to see. Actually, we won't do that here because that'll, since we're just manipulating the context, it's actually kind of harder. So we'll do the hard coding in our actual function in extern create. So instead, we want to call extern create, complete this, and then we want to give it the completions, the context, and I guess the name ref we got from before, but we'll just give it a none for now. And now we can jump over here. Oh, it's starting to get exciting now. So we're almost there to have at least have made some completion, even though obviously it's not correct yet. And after that we have to figure out where we're gonna get the correct names from. I guess we want to add a completion item. And what is completion item? Let's have a look at one of the, or maybe actually this person has completion item. So we construct a completion item and then we can add it, I guess. We'll try that. So let completion, I don't know, item equals completion item. What did I miss? Completion item and new. Okay, so we need to give it a kind. So I think this would be a crate, but a crate kind of some sort, but let's see. So this is a simple kind, okay. Completion, completion, item kind, symbol kind. What kind of symbol kinds do we have? Perfect. That's just another enum. Love the enums. So symbol kind. It should be maybe a module. I guess it's a module, right? I'm not entirely sure, but let's see. Is that what that person did? Symbol kind module, yes. I don't know what this IDB thing is. We'll get rid of that. Okay, so that's our first thing. Then we have a text range. Text range. I don't know what that would be. Can we just give it something fake? Text range. Creates a new text range with the given start and end. creates a 0 length text range in the specified offset. Okay. I guess we'll try to just use the context and then do the source range. I don't know what this is used for exactly. So we just say context dot source range. All right, and then lastly, we want a label, and hopefully this is where we can just hard code and see our test succeed. So it provides the name, and that sounds good because we can certainly provide a name, I think. I hope. So can we do a string? My crate. Okay, we'll try that. So what else do we need? This is all we need. Or is it? No. Completion item dot add to. That's interesting. So we say item dot add to completions. Okay. Roger that. What's wrong here? Do we need to import? Okay. So now we shouldn't panic. We should just get a failing test where it says that other crate, md other crate is not equal to md my crate. That's my prediction. We nailed it. There it is. Beautiful. The hard-coded my crate. And now we're gonna make the test pass. So we're gonna put in other crate. Now there's one weird thing, which is there is a new line, which I guess makes sense. So we'll have to account for that in our test. But okay, so we have the other crate here. Yeah, what test here? It's kind of weird. Why do I have these in two different files when it's just two different windows? Other crate, and can we like add a new line somehow maybe, just to make this pass? So now it could pass, assuming the strings match exactly. Our test passed. We had a new failure because the files are not tidy. Oh, these are like meta checks inside the tests. That's really cool, if I interpret them correctly. But okay, we succeeded. Let's just, to be completely sure, let's just run can complete extern. Now, did that even run anything? Who knows? Can we? God damn, it did. Yes. So we now have a fail up passing test. This is almost like some TDD nonsense. But here it made sense to just write this and understand what is even going on in all these layers, because obviously this is a complex piece of machinery. But very nice. Very nice. Now things make sense. Now we just have to fill out the missing pieces, add some more tests, check the style guide, and we're good to go.